so I'm not going to start tonight's notes in the notes. I'd like to start tonight's notes actually talking about a few things that I think students are struggling with understanding. Okay. The first thing I want us to do is to draw the image of a plane. So again, a plane is a flat surface that extends infinitely in two directions. So if we could think about this plane continuing on in this direction and then in this direction, going on and on forever, that'd be the best. Okay? And then let's say we have another plane kind of going through it. Maybe it comes back like this, right? And there we are. So there's two planes that are intersecting. Okay? A, B. So a plane is a flat surface that extends infinitely, right? It's a wall that goes on forever. Points on the plane, maybe like C, D, E here. Make sure I'm still on my picture. Okay, they're coplanar. They're on the same plane. All right. C, D, and E are coplanar because they are on the same plane. All right. If I were to draw a line through C, D, and E, this line DE would be on the plane because two of its points are on the plane. So since at least 2 points are on the plane, all of its points must be on the plane. So this line right here is on our plane. Okay? As is this line over here, AB. And they are coplanar as well, because they are both on this plane. Now they're kind of traveling in different directions, and they're going to intersect somewhere out here, right? If I were to extend this out. And this point out here, maybe G, that point is also on this plane, so if this plane were to extend infinitely out in this direction, G would be on that plane. Since D and AB are both on the plane, G would be on the plane, because G is on DE and AB. So all these things are coplanar. Now, to be collinear, you have to be on the same line. So D, E, and G are collinear. They are all on the same line. Now, I could name this plane that C, D, and E are by saying plane C, D, E. That's all I'd have to write, plane C, D, E. Okay. There's an angle on the plane, and that angle is angle CED. Okay. All right. Intersections of rays, angles, line segment, or rays, line segments, and lines. Let's talk about that. Okay. Let's say I had a ray like this, and let's call this ray AB. That's ray AB. And say I had another ray. Call this ray BA. So BA goes this way, AB goes this way. And if you can't see it, we'll outline this in purple. Ray AB goes this way. And ray BA, we have a different color. I don't have a different color. I don't have a different color. Alright, well, let me grab one. Let me grab another color. Alright. So, let's say ray BA goes this way. Their intersection is the place where the purple and the brown overlap. So their intersection is this segment right here. Segment AB. Okay? let's say I had two lines. Their intersection, where they overlap, would be this point in the middle. Right. Again, a ray is a point that starts at the first letter and goes off infinitely in one direction. Okay. So I just want to make sure I went over that before I got into the notes for today. So, notes for today are going to be page 13. And it's going to be angles on repeat. Because we're still struggling with ideas about angles. Like, we're really struggling with angles on repeat. Okay, so, page 13. And today's the 22nd. Our objective is to determine unknown angles unknown angle measure using a variety of methods. And we want to have a couple different colors handy. Okay, I don't really care what colors you pick out. I'm going to be using blue, purple, green. Okay, because we're going to make this colorful. Alright, and if you remember that chart that we made today, we're going to make that same chart in our notebook because it's really, really important that we know those 6 angle relationships. So I'm going to make a pretty chart. I'm going to use my handy dandy straight edge, which happens to be a post-it note, or a stack of post-it notes rather. And I'm going to make this very neat because I'm going to want to use this to study with if I were a student. Which I'm not, but I'm just saying that so you guys actually make it pretty neat. I'm going to have it take up, I don't know, let me zoom out. My low-tech zooming so you can see. Okay, it's going to be like, I don't know, 3/4 of the page. You need to save a quarter of the page though, so zoom back in. Using my handy dandy straight edge. I wish I knew that cool fast forward trick where you could like just fast forward through something, like on those food videos where they like snap and suddenly, you know, so it's done. In fact, I think I could do it. You ready? Wow, that was awesome that just appeared like that. That's pretty cool. Alright, so a linear pair. A linear pair have 2 of their rays forming a straight line. Okay? So these 2 angles right here are a linear pair. So relationship is they add up to 180. So the measure of angle DBA plus the measure of angle DBC is 180. They are supplements. The other supplementary angle pair happens with parallel lines. Okay? And the 2 angles that are supplementary are right here and right here. Okay? The rest of these are all congruent. So we can just fill in congruent all the way down. Amazing again, right? Okay, so the picture of vertical angles is this.
If you're in the building, please come down to the main office.
Okay, the picture of alternate interior angles. Again, these lines are parallel. Looks like this. And this one makes the Z shape. Okay. Alternate exterior. I'll get even closer. Okay, looks like this. I'm gonna make these ones green just because I used a lot of glue already. And last but not least, we have corresponding. Which look like this. Okay, it's really important that we have these different types of angles memorized. Okay. The last thing I want to talk to you about are triangles. Okay. So there's a lot of triangle buzzwords, and we're going to get some more of those over the weekend. But the first thing I want you to write down is the interior angle sum. My pen's too long. Interior angle sum of a triangle. Let me zoom out. Ooh, low tech. All right. Is 180 degrees. So that means if I have a triangle, and I knew two of the angles were 60 and 40, and I wanted to find the third angle, I do x plus 60 plus 40 equals 180 degrees. Well, x plus 100 equals 180. So x equals 80. The other thing we have to know about are isosceles triangles. And we'll talk a lot about different types of triangles here over the weekend. But for tonight, we need to know about isosceles triangles. Isosceles triangles have a pair of congruent sides and, this is the cool thing about them, the angles opposite these sides are also congruent. So in my picture, I would note an isosceles triangle, perhaps like this, and say these two sides were congruent. And those little hash marks mean congruent. Those little hash marks kind of point at the angles that are also congruent. So if I were to follow this hash mark over, I'd land over on this angle, which is congruent to the hash mark angle across from this hash mark. Boom. And then they can kind of do cool things, like they might say that suppose this angle is 40 degrees. What are the other two angles? Okay, so that's kind of neat. We know the other two angles are equal in measure, so we can call them both x. And we know that x plus 40 equals 180. So 2x is 140, so x is 70. Okay. That's it for tonight. A little bit of review and a little tiny bit of something new. Hopefully I can edit this all together and make it look really cool and get that snappy thing down, because I want to be cool like those food videos. Yeah. Talk to you later.